Hi everyone. So this is all about rectangles and their properties. So you were supposed to have created the Geometer Sketchpad sketch and analyzed different things about a rectangle. So you already know the definition of a rectangle is a parallelogram with all equal angles. Those angles all being 90 degrees. We've already gone through that. I'm just reminding you of the basics. So it is a parallelogram. So we do know that all the opposite sides are parallel, all the opposite angles are congruent, all the opposite sides are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. So those are the same properties that we have for parallelograms, and they transfer over to rectangles. But there are two different properties that you were supposed to have noticed from your Geometer Sketchpad sketch. And those properties are, number one, all right angles. Okay? So all the angles are right angles, so they're all equal to 90. So that is something that you already knew going into this. And the other property, then this is where the Geometer Sketchpad sketch really came in, are the diagonals are congruent. Unlike parallelograms, where the diagonals are not congruent, they just bisect each other, rectangles actually have them where they are actually equal. So if I go to my sketch of my parallelogram, this is a rectangle, and you'll notice that I have it as close to 90 degrees as possible. Hopefully you can see that. And AC, AE, DE, BE, CE, all of these are congruent to each other. But the minute that I
Please excuse the interruption. You start the door to students.
make this into a parallelogram,
Students may now be dismissed.
they still bisect each other. Each part is equal, but they're not equal to each other. And that is the biggest difference between a rectangle and a parallelogram. So, if we move on to our examples, first off, you should draw in these rectangles. Anytime they're talking about quadrilateral UTS, above is a rectangle. So you need to draw that in. Okay. US, this distance right here, is 6x plus 3. And RT is 7x minus 2. Now, those are diagonals. So I know that they are equal to each other because it's a rectangle. So I would do 7x minus 2 equals 6x plus 3. I then subtract 6x. And then add 2. And I get x equals 5. Now for this one, it says RUS, so it's the same thing, okay? But now they're talking about angles, okay? And it's angles STR. So I have to draw in that diagonal. That angle is 8x plus 3. Now, UTR, so this angle right here is 16x minus 9. Now, each angle here is 90 degrees, remember. So these two angles put together make that 90. So what I have to do is I have to add those together. And they're equal to 90 because they're at the same angle. So then I solve. So 8x and 16x, that's 24x. And then minus 9 plus 3 is minus 6 equals 90. And then add 6. 24x equals 96. I divide by 24, and I get that x equals 4. So those are the two examples. But those aren't the only examples that I want to go through. Let's look at 2. Okay, again, you have this rectangle already drawn for you. BE is 6y plus 2, and CE is 4y plus 6. Now before, in a parallelogram, I couldn't compare these two lengths. But because this is a rectangle, I know this length is equal to this length. Which means if these two are congruent, then these two are congruent. So all those little sections are congruent. So I can say 6y plus 2 equals 4y plus 6, and then solve. Okay, so that is my grand total 4y. For here, again, BD, this entire length is 8y minus 4, and AC is 7y plus 3. So again, I know these are diagonals, so I'm setting them equal to each other. So it's 7y plus 3 equals 8y minus 4, and then I can solve. It turns out y is 7 when I solve it. And if you can't get y is 7, please come see me later. Okay? But the trick is, it says find BD. So what I have to do is I have to take that 7 and plug it in for BD. So BD equals 8 times 7 minus 4. 56 minus 4 is 52. And I can also do the same thing here with AC just to check. 7 times 7 is 49, plus 3 is 52. And they're equal. The trick becomes now on the back side is where we're graphing, and we have to prove if it's a rectangle. We have to determine whether it's a rectangle. So the first thing you need to do is plot the points. And then you draw on these line segments. Now it looks like a rectangle, but I have to prove it. And you can't prove it without some mathematical knowledge out there. And the biggest key is that 90 degrees. 90 degrees means that it's perpendicular. And going back to parallel lines and perpendicular, we need perpendicular leads to opposite reciprocal slopes. Opposite reciprocal slopes. That means that these will intersect at a 90-degree angle. So what I do is I just find the slope of each line. So this one is A, this one is B, C, and D. So if I go A to B, I would go 1, 2, 3 over 1. So AB has a slope of 3 over 1. Okay. Here, for B to C, I would go down 2 over 1, 2, 3, 4, 5, 6. So BC is down 2 over 6, which reduces down to negative 1/3. So these two are opposite reciprocals. Opposite meaning this is positive, this is negative. Reciprocal meaning flipped. 3 over 1, 1 over 3. So those are opposite reciprocals. But I gotta check all of them. So then I just go around the figure after I've applied. Okay, C to D. Well, D is on the left-hand side from C, so I'm going to count from D. 1, 2, 3, over 1. 3 over 1. And A to D is down 2 over 6, which is also negative 1/3. So each consecutive line is perpendicular, and every other one is parallel because they have the same slope, if you remember. Parallel meaning same slopes, perpendicular meaning opposite reciprocals. And that is how you prove something is a rectangle. So now, please complete the notes and come in with any questions you have.